Magnetic effect of electric current. The production of magnetic field around a conducting wire when electric current is allowed to flow through it. It is called magnetic field of current. Right hand thumb rule assumes that you are holding a straight current carrying conductor in your right hand such that the thumb points toward the direction of the current. Then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. Magnetic field lines. A magnetic field line or lines of forces show the strength of the magnet and the direction of the magnet force. It was discovered by Michael Faraday to visualize the magnetic field. Direction of magnetic field lines. Magnetic field lines are directed from South Pole to North Pole inside the magnet and from North Pole to South Pole outside the magnet. Strength of magnetic field lines. A straight current carrying wire conductor has a magnetic field in the shape of concentric circles around it. The magnetic field of straight current carrying conductors can be visualized by magnetic field lines. The direction of magnetic field produced due to the current carrying conductor rely on the same direction on which current is flowing. The direction of electric field gets reversed if the direction of electric current changes. Suppose a straight current carrying conductor is hung vertically and an electric current is flowing from north to south, which is from up to down. In this situation, from south to north through the same conductor, the direction of the magnetic field will be anti-clockwise. The direction of magnetic field in the electric current through a straight conductor can be represented by using a right hand thumb rule. Now let's see units of magnetic field. Unit of magnetic field. Unit of V vector is mks Weber by meter square. SI unit is Tesla. CGS Maxwell centimeter of course. 1 Tesla equals to 1 Weber by meter equals to 10 to the power 4 Maxwell by centimeter. That is equals to 10 to the power 4 Gauss. Biot-Savart's law. With the help of experimental results, Biot and Savart arrived at the mathematical expression that gives the magnetic field at some point in space in terms of the current that produces the field. That expression is based on the following experimental observation for the magnetic field. dV vector at a point P associated with a length element dl vector of a wire carrying a steady current I. Magnitude of dV vector is proportional to current I, proportional to magnitude dl of the length element dl vector, inversely proportional to r square where r is the distance between dl to P, proportional to s sin theta where theta is the angle between vector dl and r. Now by combining all this we have dV directly proportional to I, dV directly proportional to dl, dV inversely proportional to r square, dV directly proportional to sin theta, dV directly proportional to I dl sin theta by r square, dV equals to mu 0 by 4 pi. Mu naught is called permeability of free space. Mu naught by 4 pi equals to 10 to the power minus 7 Henry per meter. Dimensions of mu naught equals to mLT minus 2, e to the power minus 2. For vacuum, root over 1 minus mu naught E naught equals to C equals to 3 into 8 10 to the power 8 meter square. Biot-Savart law in vector form. The direction of dV is perpendicular to a plane determined by dl vector and r vector. If dl vector and r vector lie in the plane of the paper, then dV is perpendicular to plane of the paper. In the figure, direction of dV vector is into the page. Application of Biot-Savart law. We can use Biot-Savart law to calculate magnetic responses even at the atomic or molecular level. Importance of Biot-Savart law. Biot-Savart law is similar to the Coulomb's law in electrostatics. The law is applicable for very small conductors to which carrying current acting. The law is applicable for symmetrical current distribution. Thank you. Om Namah Shivaya.